Hello everyone and welcome to this video channel Science Class 8. In the previous video class we studied the beginning portion of chapter number 15. Chapter number 15, the beginning portion of chapter number 15, some natural phenomena. Today let's continue this same topic, same chapter number 15, some natural phenomena from textbook page number 204. So let's see. In the previous video class, we studied so many natural disasters and about the propagation of sound and lightning. So today let's study from lightning safety. So first let's try to read all this thing. Lightning safety. During lightning and thunderstorm, no open place is safe. So hearing thunder is an alert to rush to a safer place. So during lightning and thunderstorm, so open place is not a safe place. So hearing the thunder sound is an alert. So during that time, we have to rush to a safer place. After hearing the last thunder, wait for some time before coming out of the safe place. So just after hearing the last thunder, then wait for some time before coming out of the safe place. So finding a safe place. Let's see. A house or a building is a safe place at a time when lightning and thunderstorm happen. Then building or a house is a safe place. If you are traveling by car or by bus, you are safe inside with windows and doors of the vehicle shut. So while we are inside a house or a building, then that is a safe place. And if you are traveling by a car or by bus, then we are safe inside the bus or car with windows and doors of the vehicle shut. So do's and don'ts during a thunderstorm. Let's see. Do's and don'ts during a thunderstorm. Outside. Open vehicles like motorbikes, tractors, construction machinery, open cars are not safe. So some don'ts. It is mentioned here, don'ts first, when we are outside. Say open vehicles like motorbikes, tractors, construction machinery, open cars are not safe. Open fields, tall trees, shelters in parks. Elevated places do not protect us from lightning stroke. So open fields, tall trees, shelters in parks, and even elevated places do not protect us from lightning stroke. So carrying an umbrella is not at all a good idea during thunderstorm. So during thunderstorm, carrying an umbrella is not at all a good idea. So, during thunderstorm. So if in a forest, say if we are in a forest, take shelter under shorter trees Then if we are in the forest, then thunderstorm happens, then we have to take shelter under shorter trees, not tall trees. If no shelter is available and you are in an open field, stay far away from. This should be tall. Here the word ALL is printed, it is wrong. So stay away from tall trees. It should be tall. So we can put here T, tall trees. Stay away from poles or other metal objects. Do not lie on the ground and instead squat low on the ground. So if no shelter is available and you are in an open field, then stay far away from the tall trees and stay away from poles or other metal objects. So we should be away from the metal objects. And do not lie on the ground. We should not lie on the ground and instead squat low on the ground. Squat means sitting in this position. That is called squat. Squat low on the ground. Place your hands on your knees with your head between the hands. As shown in this picture, figure number 15.6, it is shown here. So this position will make you the smallest target to be struck. So if we are in an open field, then there is no shelter, then we are better to lie in this squat low on the ground, and we have to put our head in between the hands in this position. So this will be the position which will make you the smallest target to be struck by the lightning. Figure number 15.6, shape position during lightning is shown here. Inside the house, let's see, inside the house, lightning can strike telephone cords, electrical wires and metal pipes. Do you remember lightning is an electrical discharge? So lightning can strike telephone cords, electrical wires and metal pipes. And here also, and do you remember lightning is an electrical discharge? Lightning actually is an electrical discharge. During a thunderstorm, contact with these should be avoided. So during the thunderstorm, the contact of such type of things like electrical wires and metal pipes, these things we should not contact. It is safer to use mobile phones and cordless phones. So during the thunderstorm, we are better to use cordless phones like mobile phones. So however, it is not wise to call up a person who is receiving your phone through a wire phone. So it is also not wise to call up a person who is receiving your phone through a wire phone. Say you are using a mobile phone, cordless phone, and the person you call use say wire phone. So for him it is not wise to receive the phone during the thunderstorm. Bathing should be avoided during thunderstorms to avoid contact with running water. So here bathing should be avoided. Bathing should be avoided during thunderstorms to avoid contact with running water. So electrical appliances like computers, TVs, etc. should be unplugged. electrical lights can remain on. They do not cause any harm. So electrical appliances like computers, TVs, etc. Should be unplugged, and electrical lights can remain on and they do not cause any harm. So these are the measures, these are the do's and don'ts during a thunderstorm. And in the next page, let's move. Page number 215, lightning conductors. What are lightning conductors? Let's see. Lightning conductor is a device used to protect buildings from the effect of lightning. So lightning conductor is nothing, it is a device used to protect buildings, tall buildings, from the effect of lightning. Say a metallic rod taller than the building is installed in the walls of the building during its construction. One end of the rod is kept up in the air and the other is buried deep in the ground. As figure number 15.7, it is shown here like this. So the rod provides easy route for the transfer of electrical charge to the ground. So lightning conductor is nothing, it is a device used to protect buildings. So it is a metallic rod taller than the building and is installed in the walls of the building during its construction. So one end of the rod is kept out in the air and the other is buried deep in the ground. It is shown in this picture. Yes, like this. This is the lightning conductor, and one end is above the building and it is carried like this under the ground. So it will protect the building. So in this modern world, tall buildings, say we know as skyscrapers, are constructed. So use of this lightning conductor will protect the building. So the metal columns used during construction, electrical wires and water pipes in the buildings also protect us to an extent. So but do not touch them during a thunderstorm. So during a thunderstorm, such electrical wires and water pipes we should not touch. Earthquakes. Let's see earthquakes. You just learned about thunderstorms and lightning. In class 7, you learn about cyclones. So this natural phenomena can cause large-scale destruction of human life and property. So fortunately, this phenomena can be predicted to some extent. The weather department can warn about a thunderstorm developing in some areas. So the thunderstorm developing in some areas can be warned some minutes ahead or 1 day or 2 days ahead. The weather department can warn about the thunderstorm developing in some areas. And if a thunderstorm occurs, there is always a possibility of lightning and cyclone accompanying it. So if thunderstorm occurs, then there is always possibility of lightning and cyclones. So we get time to take measures to protect ourselves from the damage caused by these phenomena. So you just have seen about the installation of, say, lightning conductor in a tall building. Is like this. So lightning conductor, it is above the building. So it is like this copper plate under the ground. It is like this lightning conductor. It is during the construction of the building. It is fitted in the at the time of construction in tall buildings. In the next page, page number 216, let's see. Textbook page number 216. There is, however, one natural phenomenon which we are not yet able to predict accurately. There is also one natural phenomenon which we are not yet able to predict accurately. So it is an earthquake. The natural phenomenon is what earthquake. Till now we cannot predict. So it can cause damage to human life and property on a huge scale. So earthquake can cause damage to human life as well as property. So a major earthquake occurred in India on 8 October 2005 in Uri and Tangdar towns of North Kashmir. It is shown in figure number 15.8 below. Figure 15.8 below. So, before that, a major earthquake occurred on 26 January 2001 in Bhuj district of Gujarat. So, on 8 October 2005 in Uri and Tangdar towns of North Kashmir. And before that, on 26 January 2001 in Bhuj district of Gujarat. So, in that earthquake, loss of human life as well as loss of properties, buildings are there. Say this is the figure Kashmir earthquake. It is shown like this. Most of the buildings destroyed during that earthquake. Activity 15.1. Ask your parents about the huge damage to life and property caused by these earthquakes. Collect a few pictures showing the damage. So you can ask your parents about the huge damage to life and property caused by the earthquake. And you can also collect a few pictures from the newspaper about the damage caused by earthquake. Here, showing the damage caused by these earthquakes from newspaper and magazines of those days, and prepare a short report on the suffering of the people during and after the earthquakes. So most of the people suffer during the earthquake as well as after the earthquakes. So after the earthquakes, because of the collapse of the buildings, most of the people, they may be homeless. Okay, next let's see what is an earthquake and what happens when it occurs. What can we do to minimize its effects? These are some of the questions which we shall discuss below. Here let's see what is an earthquake. So what happens when it occurs and what can we do to minimize its effects? So these are some of the questions which we shall discuss below. So what is an earthquake? Let's try to learn first this thing. An earthquake is a sudden shaking or trembling of the earth which lasts for a very short time. So it is caused by a disturbance deep inside the earth. So earthquake is caused by a disturbance deep inside the earth. So it is nothing, it is a sudden shaking or trembling of the earth and which lasts for a very short time. That is called earthquake. The next page, let's move. So it is caused by a disturbance deep inside the earth's crust. Earthquakes occur all the time, all over the earth. They are not even noticed. Major earthquakes are much less frequent. They can cause immense damage to buildings, bridges, dams, and people. So here it says earthquakes occur all the time, all over the earth, but major earthquakes are much less frequent. So they can cause immense damage to buildings, bridges, dams, and people. And there can be a great loss to life and property. Earthquakes can cause floods, landslides, and tsunamis. A major tsunami occurred in the Indian Ocean on 26 December 2004. All the coastal areas around the ocean suffer huge losses. So, a major tsunami that was occurred in the Indian Ocean on 26 December 2004. All the coastal areas around the ocean suffered huge loss during that time. And activity 15.6, let's see. Take an outline map of the world. Locate the eastern coast and Andaman and Nicobar Islands in India. Mark other countries around the Indian Ocean which could have suffered damage. Collect accounts of the devastation caused by the tsunami in India from your parents or other elders in the family or in the neighborhood. So this is an activity. You have to take an outline map of the world and locate the eastern coast and Andaman and Nicobar Islands in India. So Andaman and Nicobar Islands, they are part of India. So mark other countries around the Indian Ocean and which could have suffered damage. So, and collect accounts of the devastation caused by the tsunami in India from your parents. So the devastation caused by the tsunami in India, you can collect information from your parents and other elders in the family or from your neighborhood also. What causes an earthquake? My grandmother told me that the earth is balanced on the horn of a bull, and when the bull shifts it to the other horn, an earthquake takes place. How could it be true? So this is based on the belief of mythological belief. That means, say, my grandmother told me that the earth is balanced on the horn of a bull, and when the bull shifts it to the other horn, then an earthquake takes place. How could it be true? So this is about the mythological belief. So let's continue. In ancient times, people did not know the true cause of earthquakes. Their ideas were therefore expressed in mythical stories, such as the one told by Buzo's grandmother. This is spoken by the Buzo's grandmother. Similarly, myths were prevalent in other parts of the world. So, in the ancient time, most of the people, they do not know the true cause of the earthquakes. So, thereby, they traditionally believe the mythological beliefs are there. So, next, what could cause a disturbance inside the earth? Now, we know that the tremors are caused by the disturbance deep down inside the uppermost layer of the earth, called the crust. So, we know that tremors, sudden shaking of the earth, are caused by the disturbance deep down inside the uppermost layer of the earth. So, that is called crust. So, here the structure of the earth is shown here, and this is the crust, mantle, and outer core is mentioned here, and this is the inner core. Inner core is at the inside, and next one is outer core, and next mantle and crust are shown in this structure of the earth. The outermost layer of the earth is not in one piece, so it is fragmented, and each fragment is called a flat. Figure number 15.10, it is shown below. So these plates are in continual motion when they brush past one another. So here what it says, the outermost layer of the earth is not in one piece, so it is fragmented, and each fragment is called a flat, and it is shown in figure number 15.10. Say here fragments of the outermost layer of the earth is shown, and here Eurasian flat, Arabian flat, and Indian flat, it is named as like this. So these plates are in continual motion, and when they brush past one another, or in the next place, let's see, a plate goes under another due to collision. So figure number 15.11, they cause disturbance in the Earth's crust. It is this disturbance that shows up as an earthquake on the surface of the Earth. So here we have just seen colliding of that fragments brushing past is shown here like this, and figure number 15.11, movements of Earth's plate is shown here. And here one question arises: if say scientists know so much about earthquakes, can they also predict when and where the next one will strike? So if scientists know so much about earthquake, then can they also predict when and where the next one will strike? Can they predict? There is one question. So now let's continue. Although we know for sure what causes an earthquake, it is not yet possible to predict when and where the next earthquake might occur. When and where the next earthquake might occur, we cannot predict till now. And here is one more question. I read somewhere that underground explosions could also cause tremors. Tremors means sudden shaking of the earth crust. This says, I read somewhere that underground explosions could also cause tremors. Underground explosion also could cause tremor. Let's see. Tremors on the earth can also be caused when a volcano erupts. So volcanic eruption also can cause tremors, so sudden shaking of the earth, or a meteor hits the earth. When a meteor hits the earth, then sudden shaking of the earth, that is tremors, can happen. Or an underground nuclear explosion. Underground nuclear explosion also can cause tremors. So underground nuclear explosion is carried out. However, most earthquakes are caused by the movement of Earth's plates. So most earthquakes are caused by the movements of the Earth's plates. Since earthquakes are caused by the movement of plates, the boundaries of the plates are the weak zones where earthquakes are more likely to occur. The weak zones are also known as seismic or fault zones. In India, the areas most threatened are Kashmir, Western and Central Himalayas, the whole of Northeast, Rann of Kutch, Rajasthan, and the Indo-Gangetic Plain. Some areas of South India also fall in the danger zone. So earthquakes are caused by movement of the plates. The boundaries of the plates are the weak zones where earthquakes are more. So in India, earthquake zones are mentioned here, that is Kashmir, Western and Central Himalaya, the whole of Northeast region, Rann of Kutch, Rajasthan and Indo-Gangetic Plain, and some areas of South India also fall in the danger zone of earthquake. So in this picture, the Eurasian plate is shown here, Tibetan plateau and Himalayas region, then Ganges plain, Indian plate, Mount Everest lies here. So, and most part of the northeastern region, they also belong to danger zone of the earthquake. So, movements of Indian earth plates. The power of an earthquake is expressed in terms of a magnitude on a scale called the Richter scale. So the power of an earthquake is expressed in terms of a magnitude that is called Richter scale. So really, destructive earthquakes have magnitudes higher than 7 on the Richter scale. So a destructive earthquake that is measured higher than 7 Richter scale. So both Bhuj and Kashmir earthquakes had magnitudes greater than 7.5. So the earthquake magnitude that occur in the Bhuj and Kashmir, they are greater than 7.5 Richter scale. In the next page, let's move. The tremors produce waves on the surface of the earth. These are called seismic waves. The waves are recorded by an instrument called the seismograph. So the tremor wave is measured by an instrument that is called seismograph. And figure number 15.13, it is shown here. The instrument is simply a vibrating rod or a pendulum which starts vibrating when tremors occur. As pen is attached to the vibrating system, the pen records the seismic waves on a paper which moves under it. By studying these waves, scientists can construct a complete map of the earthquake, as shown in figure 15.14. So here, they can also estimate its power to cause destruction. So seismograph is shown here. When the tremor or the shaking of the earth happens, then this pole will move and it will draw chart paper. In the chart paper, movement of this pendulum will draw like this. So this is the string, this is pendulum bob, rotating drum, pen is here. And when we remove this chart, then we can see this marking. It shows the magnitude of the earthquake. And here, map of the earthquake. Say focus is here, earth's surface is here, epicenter is this, and seismic waves are shown here. So map of the earthquake. Now let's continue. Like many other scales in science, decibel is another example. Let's see. Richter scale is not linear. This means that an earthquake of magnitude 6 does not have 1.5 times the destructive energy of an earthquake of magnitude 4. In fact, an increase of 2 in magnitude means 1000 times more destructive. An increase of 2 in magnitude means 1000 times more destructive energy. Therefore, an earthquake of magnitude 6 has 1000 times more destructive energy than an earthquake of magnitude 4. So here is the difference it shows. Next, protection against earthquakes. How can we protect from the earthquake? Let's see. We know from the earlier pages that earthquakes cannot be predicted. We have also seen that they can be highly destructive, and it is therefore important that we take necessary precautions to protect ourselves all the time. So yes, it is quite necessary to protect ourselves from the earthquake. So people living in seismic zones where the earthquakes are more likely to occur have to be specially prepared. First of all, the buildings in these zones should be so designed that they can withstand major tremors. Modern building technology can make it possible. So here it means it says about the protection from the earthquake. So modern building technology even can also make possible in order to protect from the earthquake. Next, page number 220, let's continue. It is advisable to make the structure simple so that it is quake safe. Consult qualified architects and structural engineers. So when we want to construct building, so we should consult with a qualified architects and structural engineers in order to protect from the earthquakes. In highly seismic areas, the use of mud or timber is better than using heavy construction material. So in the highly seismic area, the use of mud or timber is better than using heavy construction material. So keep roofs as light as possible. So we should construct the roofs as light as possible. When the earthquake happens, then we can protect from it, not to happen damage of the lives or the life loss, not to happen life loss. So in case the structure falls, the damage will not be heavy. So it is better if the cupboards and shelves are fixed to the walls so that they do not fall easily. So cupboards and shelves are better to fix to the walls so that they do not fall easily when tremors or earthquakes happen. And be careful where you hang wall clocks, photo frames, water heaters, etc., so that in the event of an earthquake, they do not fall on people. So at a time when wall clocks, say photo frames, water heaters, when we should manage these things properly, when earthquake or tremors there, then they do not fall on the people, not to fall on the people. Since some buildings may catch fire due to an earthquake, it is necessary that all buildings, especially tall buildings, have firefighting equipment in working order. So in some buildings, even they may catch fire due to an earthquake. So it is necessary that all buildings, especially tall buildings, have firefighting equipment. And the Central Building Research Institute, Roorkee, has developed know-how to make quake-resistant houses. Central Building Research Institute, Roorkee, is one of the organizations, and it has developed know-how to make earthquake or quake-resistant houses. So in the event that an earthquake does strike, take the following steps to protect yourself. So here, if you are at home, take shelter under a table and stay there till the shaking stops. So this is the precautionary measure when we are at home. If earthquake happen, so these points we have to note down, and stay away from tall and heavy objects that may fall on you. So we have to stay away from tall and heavy objects. And if you are in bed, do not get up. Protect your head with a pillow. So if you are on the bed, then do not get up. Protect your head with a pillow. And point number 2, if you are outdoors, say suppose if you are in the outdoors and if earthquake happen, then what shall we do? Some precautionary measures are here. Find a clear spot away from buildings, trees, and overhead power lines. Drop to the ground. And point number 2, if you are in a car or a bus, do not come out. Ask the driver to drive slowly to a clear spot. And do not come out till the tremors stop. Say, if we are in a car, when the tremor is happening, when we are inside a car or a bus, then do not come out. We should not come out. Then we have to tell the driver to drive slowly to a clear spot. And do not come out till the tremor stop. So these are the precautionary measures. So for the YouTube, this video textual questions I will send, and extra question and answers YouTube teacher, Google Meet teachers will send you. And for me, extra questions I don't send. I will send only the textual questions. With that, we end this video class for today. Let's stop here. Bye.